All right, everyone, ready for a deep dive? We're talking large language models today, LLMs. Those AI systems, building websites, composing poems, maybe even, answering your emails. We're hearing more and more about how AI is going to outthink us all. But how true is that really? Because get this, there's a new study out there, and it kind of throws a wrench into things, especially when it comes to, well, something we thought was pretty basic, math. Today we're looking at a paper called, get this, GSM Symbolic, Understanding the Limitations of Mathematical Reasoning in Large Language Models. Sorry, we'll unpack all that jargon in a bit. Lucky for us, we've got our AI expert on hand to break it all down. What's got you so into this research?
See, the wild thing is, it's not just about whether these LLMs can, pass a math test. It's about figuring out, are these systems actually reasoning the way you or I would? Or is something else entirely going on behind the scenes?
Ooh, sneaky. How'd they even go about testing that?
Okay, so they use this thing called a benchmark GSM Symbolic, which basically just a bunch of grade school math problems. We're talking addition, subtraction, that kind of thing. But here's what gets interesting. They created all these different variations of the problems. Like, on the surface, they look different, but the underlying math, exactly the same.
So it's kind of like giving someone 100 versions of the same math test, just shuffling the numbers and words around.
Exactly. The thing is, if you understand the core concepts, those little changes shouldn't trip you up. But for LLMs, well, that's where things get a little weird.
Okay, hit me with it. What happened? Did the LLMs ace the test or what?
All right, get this. The same LLM would totally nail some versions of a problem. And then, you wouldn't believe it, completely bomb others, even though the math was, identical.
Wait, seriously? That's wild. Like, imagine if a student aced their multiplication tables 1 minute, then totally forgot how to add the next. What's the deal with that?
See, that inconsistency right there, that's the big clue. It kind of suggests that LLMs might be relying on this brute force memorization thing. They're not really understanding the math. It's more like they're trying to find a problem they've seen before and just repeating the answer.
So instead of using logic, it's like they're playing some supercharged matching game.
Exactly. Think of it like trying to learn a new language, but all you do is memorize phrases from a phrase book. You might be able to string a few sentences together, but you wouldn't actually get the grammar or be able to have a real conversation. And this whole pattern matching thing, well, it might explain why LLMs get tripped up in some pretty surprising ways.
Okay, you got to spill the tea on this one.
So the researchers actually found that LLMs are more easily confused by changes in numbers than they are by changes in, say, names in a problem.
Hold up. How does that even make sense? Swapping out Alice for Bob has got to be less confusing than changing, 5 apples to 7 apples.
You'd think so, right? But it seems like LLMs, they get really fixated on those specific numbers, those values they saw during training, even if those exact numbers aren't actually important to the problem itself.
So it's not that they can't handle numbers in general, but they get kind of stuck on the specifics of what they've seen before.
Exactly. And this stuck on specifics thing, well, it might also explain why they had such a tough time when the problems got a bit longer, more complex.
So it's like their mental filing cabinet's overflowing.
Yeah.
Too many folders and things start getting lost in the chaos.
And you know what? To really put this whole pattern recognition idea to the test, the researchers came up with a pretty ingenious trick. They call it the no-op trap. Basically, they started slipping information into the math problems, stuff that sounds important, but is actually totally useless for solving the problem.
Ooh, I'm intrigued. What kind of sneaky information are we talking here?
Okay, so imagine you're trying to figure out, how much money you have left after grocery shopping, right? But then someone throws in a random detail about, I don't know, how many donuts you bought earlier that week.
Okay, delicious, but completely irrelevant. Donuts have nothing to do with my grocery budget.
Exactly. But LLMs, they fell for it. Hard. Instead of recognizing that the info was useless, they tried to force it into the equation somehow.
So they were so busy trying to find any kind of pattern that they missed the actual problem they were supposed to be solving.
It's like they have this kind of tunnel vision, fixated on the patterns they already know, and they have a really hard time adapting when something new pops up.
That's kind of unsettling, right? I mean, we rely on these calculators, computers for accuracy, and here they are getting outsmarted by a few irrelevant donuts.
It really highlights the difference between what we call artificial intelligence and actual, human intelligence. LLMs are amazing at pattern recognition, no doubt, but they don't seem to have that same adaptable intelligence that lets us reason through new, unfamiliar problems.
So they're great at following the rules they've learned, but not so much when the rules change or there's a curveball.
That's the heart of it. If we want AI systems to really collaborate with us, solving complex problems in medicine, engineering, heck, even just dealing with all the information thrown at us every day, we need them to go beyond simple pattern matching.
We need them to reason, adapt,
Hmm.
maybe even ask for help when they're stumped.
Now you're getting it. Imagine an AI that could actually say, hey, this information seems important, but I'm not sure how it fits in. Can you clarify? That's the kind of true collaboration we're aiming for.
It's like the difference between an assistant who just blindly follows orders and a teammate who actually understands the goal and can contribute creatively.
Exactly. And while this research might seem a little bit, a reality check, it's also incredibly exciting.
Right.
Because knowing these limitations, that's the first step to overcoming them.
So back to the drawing board for the AI masterminds.
In a way, yeah. But it's more like they've been handed a new piece of the puzzle. They can use these findings to design new training methods, experiment with different approaches, all with the goal of creating AI that doesn't just mimic, but actually understands.
It's like we've been trying to teach AI to solve a jigsaw puzzle by just showing it the finished picture. But what we really need to do is teach them to recognize the individual pieces, the edges, how it all fits together to create that bigger picture. That's a really cool way to put it. So where do we go from here? I mean, this is all pretty cutting-edge stuff, right? Should we be excited, worried, maybe a little of both?
I'd say it's a mixed bag for sure. I mean, on the one hand, we can't just assume that building bigger, more powerful AIs is magically going to, make them independent thinkers.
It's not just about cramming more data into their AI brains, right?
Yeah.
Like problem solved.
Exactly.
Yeah.
But look, this research isn't saying LLMs are doomed to just be stuck in this pattern matching loop forever. It's more like it's highlighting that the way we're building them now, well, it might not be the best way to get to that, true AI reasoning.
So more of a course correction than a dead end.
Yeah, that's a good way to think about it. This research is actually super valuable because it gives these AI developers some vital clues. Now, they can experiment with totally new training methods, different approaches, all with the goal of getting AI to move beyond simple pattern recognition to genuine understanding.
Okay, so instead of just throwing more data at the problem, it's more about like fundamentally changing how these AIs think, making them more strategic.
Absolutely. And imagine what we could do if AI could actually understand the information it was processing.
Whoa, yeah. We could have these AI partners in scientific discovery, helping us unlock the secrets of the universe, or curing diseases, or even just like helping us make better decisions about these huge, complicated issues like climate change.
The possibilities are kind of mind-blowing when you think about it. And it all starts with, asking the right questions, pushing the boundaries of what we think AI can do, never just settling for good enough.
So there you have it. LLMs. Maybe not quite the math geniuses we thought they were, but the journey to make them smarter, more capable. Well, it's just getting started. This whole deep dive has definitely given me a lot to think about. And I'm sure it's got your brains buzzing too, right? I mean, if these super advanced LLMs can be fooled by these seemingly simple tricks, what other blind spots might they have when they come face to face with, the real world? And what does that mean for the future of work, for education, even for creativity? I don't know about you, but my brain is definitely feeling a little bit fried right now. It's like we've been thinking about AI in one particular way.
Yeah.
And this research is kind of flipping the script.
It is. It really is. It's making us rethink some pretty fundamental assumptions.
So, big picture, what does this all mean? I mean, we've been hearing so much hype about AI and all the ways it's going to change the world, but
It's exciting, don't get me wrong.
Yeah.
It's just maybe we need to recalibrate our expectations a little bit.
so should we be hitting the panic button?
Mhm.
Or are we still on track for, AI revolutionizing everything?
I wouldn't say panic button just yet. It's more like, remember how we were talking about AI being a teammate?
Right.
Well, right now, they're kind of like that teammate who's still learning the ropes.
They've got potential, but they need a bit more training.
Exactly. And maybe a bit more guidance, too. That's where we come in, right? Humans, we're still the ones who really understand the goals, the nuances of the problems we're trying to solve.
So it's not about replacing human intelligence. It's about figuring out how to make AI a more effective tool, a true partner in problem solving.
Exactly. And this research, it's actually given us a much clearer roadmap for doing just that.
So instead of just trying to outdo humans, we should be focusing on building AI that complements our strengths and compensates for our weaknesses.
Now you're talking. Imagine Doctors who have AI assistants that can analyze massive data sets of patient information, spot patterns that humans might miss. Or engineers who can collaborate with AI to design more sustainable cities.
Or even just like AI that helps us sift through all the information overload and focus on what's truly important.
Exactly. The possibilities are, well, limitless, really.
Well, that's a pretty hopeful note to end on. LLMs, not quite ready to take over the world, but with a little help from their human friends, they might just surprise us yet. This has been an incredible deep dive. Seriously, I've learned so much. Huge thanks to our expert for, well, being an expert, and to all of you out there for joining us on this journey into the world of AI. Until next time, keep those minds curious, and remember, sometimes the most groundbreaking discoveries come from asking the simplest questions.